Hey everybody, Mr. Smith here. Welcome to another video lesson. In this video, we're going to continue talking about solving quadratics. So this is what we started talking about in class last week. We're going to talk about a couple different methods of solving quadratics. We did factoring last week, and this video is going to be all about solving by using square roots. So I'm going to show you what that means, show you how we do that. Okay. Before we can actually talk about solving with square roots, we need to talk about simplifying radical expressions. I know there's a lot of words and there's a lot going on the screen right now. I'm going to break down what we're looking at here. If you take a look at this right here, in this class we're going to deal with things called radicals quite a bit. By radical, I mean this square root sign. Okay, that's what we call the radical sign. So anytime you have something like that, we call that a radical expression. You've got a root sign like that. Okay? And the thing on the inside, the number on the inside there, we call that the radicand. We're going to deal with these things pretty often in this class. Okay? The way that we're going to break these things down and simplify is by using perfect squares. By perfect squares, I mean numbers that have a square root. So you got 1, 4, 9, 16, 25, 36, 49. You could continue this on, right? You got 8 and 64. You got 9 and 81. Just numbers that have a perfect square. That's all I'm talking about. Have a square root. We're going to use those numbers, and we're also going to use this rule down here. It's called the multiplication property of square roots. And really all it says is this. If you have a radical with some things inside of it that are being multiplied together, you can break up whatever's inside of there, okay, and multiply those things together underneath their own radical. You can take what's inside the radical and split it all up, basically, is what that says. So a little example of how that logic goes. If you have the square root of 500, and you rewrite 500 as 100 times 5, that's the same thing, right? You can break this up as the square root of 100 times the square root of 5. So it's like you're taking what's inside of that radical and you're breaking it up. You're multiplying those things together and putting them all underneath their own radical sign. Okay? And then at the very end here, I look at both of these pieces and I say, hey, the square root of 100, well, I know that that is 10. And the square root of 5 is just some decimal, so I leave that as square root of 5. That's the process we're going to be working through a little bit here at the beginning. Okay, so I'm going to give you an example or two of that. Sorry, I've got some stuff in here to erase. So let's do an example of this. We'll look at this first one, the square root of 48. It says I want to simplify it. Okay, so remember, we got to use perfect square numbers. So I'm going to write up my perfect square numbers. We can use 1, 4, 9, 4 times 4 is 16, 5 times 5 is 25, 6 squared is 36, we got 49, we got 64, we got 81. These are all perfect square numbers that we can use to break this thing up. All right, so I'm going to look at this number, 48, and I'm going to ask myself, how can I rewrite this as perfect square numbers getting multiplied together? Okay, I want to break it up using perfect square numbers and factor it using a perfect square number. If you're not quite sure where to start with this, my suggestion would be to get out a calculator and just start dividing 48 by all these numbers until you get one, okay? The other thing is that we want to use the biggest one that we possibly can. So I'm just going to start dividing here, 48 divided by 4. Well, that works, but I think I might be able to get a little bit bigger than that. What if you did 48 divided by 16? That works, and I don't think you can get much bigger than that. So 48 can be rewritten as 16 times 3. Again, like I said, 4 also goes into 48, but 16 is bigger, and we want to use the bigger option. Okay? All right, so I just rewrote this as 16 times 3. Now what I'm going to do is use that little rule from the previous slide, and I'm going to rewrite this thing in underneath the radical sign. I'm going to break that up. I'm going to turn this into the square root of 16 times the square root of 3. Just take that and I break it up, and I put both of those numbers underneath the radical. Now I look at them one at a time. The square root of 16 is 4, and the square root of 3 is just some decimal, so I leave it as the square root of 3, and this is where I'm going to end up. Okay. Let's do another one. Square root of 243. So again, we're looking at 243. We're saying, how can I rewrite this using perfect square numbers from up here. So again, if you don't know where to start, just get out a calculator, start dividing 243 by these perfect square numbers until you get one that works. Okay, so divided by 243 divided by 9, that works, but you might be able to get a little bit bigger, so let's keep trying. 16 doesn't work. 25 doesn't work. 36 doesn't work. That's not dividing evenly. That's what I mean. 43 divided by 49, that doesn't divide evenly. 64 doesn't divide evenly. I'm doing this on a calculator if you're wondering what's up with the awkward pauses. 243 divided by 81, that works. So I can rewrite 243 as 81 times 3. And again, I got that just by dividing 243 by all these numbers until I got one that worked. Okay? I'm gonna use my little rule, break this thing up, write them both underneath the square root, look at it one at a time. So the square root of 81 is 9, and the square root of 3 is just some wacky decimal. Okay, that's what I'm gonna add. Let me do one more just to show you. I'll do this last one since there's a coefficient, that 3 in front there. If you have something in front of there, same goes for this negative sign in this other example. Ignore whatever's in front, just focus on simplifying the radical, and then at the very end you'll deal with whatever that number is out front. So let's just focus on simplifying this 150. 25 goes into 150 6 times, so I could rewrite this as 3 times the square root of 25 times 6. And I'm just ignoring the 3. I'm keeping it with me that whole time, but I'm not really doing anything with it. So I break it up, write both of those underneath the square root. Square root of 25 is 5, so now this is 3 times 5 times the square root of 6. Now I can look at this and decide what it's going to be. So 3 times 5 is 15. And that's square root of 6 there as well. Okay, so it's just a couple examples on breaking down radicals. We're going to do this a little bit more in class. So just think we're using perfect square numbers to break this thing up. That's really the goal. All right, now that we know how to do that, let's go back to solving with square roots, because that's the point of this video, right? We want to be able to solve a quadratic equation by taking a square root. So I know there's a lot of words here. I'm going to direct your attention to these steps right here. Here's the steps that we're going to go by to solve something using a square root. First, we want to isolate the thing that is being squared. Okay, so you find what's being squared in your equation. You want to get that completely by itself. And you're going to take a square root of both sides. I'll tell you what this plus and minus means. It's going to be really important for us. And you're going to solve the rest from there. So let me show you an example. 5x squared plus 12 equals 72. Remember, part 1. First thing I want to do is isolate what's being squared. So I'm going to look at this equation. X squared is the thing that's being squared. 5 is not included in that. It's just x squared. So I want to get that by itself. Okay, so first I'm just going to solve it like I'm solving an equation. So I'll need to subtract 12. 5x squared equals 60. And again, you're trying to get x squared alone, so I'll divide by 5 to get rid of that. And have x squared equals 60 divided by 5. That's 12. Okay. Now I've got the x squared all by itself. The thing that is being squared is alone. Okay, so now what I'm going to do is take a square root of both sides. Because remember, I'm trying to get x by itself. I'm trying to solve for x. And it's being squared. So I'm asking myself, well, how can I undo that? How can I get rid of a squared? And the way that I do that is by taking a square root. Okay, and whatever I do to one side, I also do to the other. So the square root of x squared is just going to be x. And then the square root of 12, I'm going to have to break that down and see what I get. Okay, but before we do that, I have to tell you about this thing called the plus and minus. All right, and here's what we mean by plus and minus. Basically what it means is this. If you take a square root when you're solving, you have to add a plus minus in front of whatever you just took the square root of. And that's giving you two numbers. It's saying this could either be positive square root of 12 or it could be negative square root of 12. And the reason for that is this. Let's say I ask you what the square root of 4 is. Okay. Well, you probably immediately say, Well, Mr. Smith, that's 2. And you're not really wrong about that, right? Because 2 times 2 is 4, and that's what it takes to be a square root. But what about negative 2? Right? Isn't negative 2 times negative 2 also positive 4? So then couldn't you also say that negative 2 is also the square root of 4? Because both of them work. So then the question is like, well, can both of them be the square root? And the answer is yes, because when we're solving, when we take a square root, when we're solving an equation, we might introduce a negative into that. Don't really know. You could have the positive answer or you could have the negative answer. They could both be the square root. Okay, so the plus minus is giving you 2 things, giving you 2 numbers, giving you the positive square root and the negative square root. Okay, we'll talk about it more in class if that's a little confusing. But let's finish this out. So I want to simplify square root of 12 just like we did before. So I'm looking for perfect square numbers that go into 12. I could use 4, so it's going to be 4 times 3. Again, we can break that up. And the square root of 4 times the square root of 3. And the square root of 4 is just 2. Okay. So my final answer is going to look like this. X equals plus or minus 2 times the square root of 3. And again, what that means is that x could be positive 2 root 3, or x could be negative 2 root 3. That's all the plus or minus tells you. It's just giving you 2 numbers. Okay, it's either the positive option or the negative option. So burn it into your brains right now. When you take square root, when you're solving an equation, you have to add the plus minus. So if I'm grading your quizzes or looking at your tests or something like that, and somebody forgets to add the plus minus, I don't know what I'm going to do. I'm going to like punch my hand through my laptop and throw my headset against the wall or something, and it's going to be a bad day for me. All right, it's going to be a bad day for me. So don't forget your plus minus. Do not forget your plus minus. Very, very important. Let's do one more example, and that'll wrap it up for this video. So I'm looking at this. First, I want to isolate the part that's being squared. This one's a little bit different than the previous example because now x minus 4, that entire thing is being squared. So I got to get that whole expression by itself. I'm going to get x minus 4 squared all alone. Okay? So first, I'll add 1. We're just solving this. So that's going to be negative 2 times x minus 4 squared equals negative 88. And then I got to get rid of this negative 2. It's being multiplied, so I'll divide everything by negative 2. And then I'll have x minus 4 squared equals positive 44. At this point, notice how I did not distribute that exponent. Okay, notice how I'm not going to like divide by 2 to get rid of that exponent. Instead, I'm just getting this thing that's being squared completely alone. Okay, now that it is alone, I can do what we did before and say I want to get rid of the squared, right? And in order to get rid of that, I just got to take the square root. And that's going to leave me with x minus 4 equals plus or minus the square root of 44. Okay. All right, so we got a couple more things that we need to do here, and then we'll be done with this problem. I can simplify the square root of 44. I can rewrite that as 4 times 11. Keep simplifying it. I'm going to break it up into square root of 4 times square root of 11. Oops. X minus 4 equals plus or minus the square root of 4 is 2 times the square root of 11. Okay. And now one more thing. Again, the goal is to get x by itself. I don't have x by itself yet. I got to do one more thing. I need to add 4 to get x by itself. So I'm going to do that. I'm going to add 4 to both sides. Okay. Important thing right here. You always write your answer with the plus or minus in the middle. Okay. The plus minus goes in the middle every time. All right. So it's going to look like this. I added a 4 over here, so it's going to be 4 plus or minus 2 times the square root of 11. All right? Now that I've got x all alone, I got my plus minus. I simplified my radical completely. I'm all done. Okay? All right, so that's going to do it for this video. If you are still watching, congratulations for hanging in there. Email me and tell me, what did you have for breakfast this morning? What did you have for breakfast this morning? If you're still watching, I want to know, all right? Email if you got any questions, and we'll see you guys.